Welcome to Tanu Science. In this video, we'll learn the NEET questions from question number 121 to 135 in the year 2020, Physics Code G3. Number is 121. Light with an average flux of 20 watt per centimeter square falls on a non-reflecting surface at normal incidence having surface area 20 centimeter square. The energy received by the surface during the span of 1 minute. So this is time. Let us consider this is non-reflecting surface. Non-reflecting surface area is 20 centimeter square. The average flux, that intensity is 20 watt per centimeter square. 1 minute we can convert to second, so 60 second. Now energy received by this surface is equal to I A into T. E is equal to I is nothing but the average flux, light intensity 20 into area is 20. Here a flux is 20 watt per centimeter square, area is centimeter square, so no need to convert into meter square. So I you can take as 20, then A you can take as 20, then T is 1 minute, 1 minute is 60 second. So that E is equal to, if you multiply these three, you will get 24 into 10 power 3 joule. This is energy received by the surface during the span of 1 minute time. Question number 122. A ray is incident at an angle of incidence I on the surface of small angle prism. So let us consider this is prism. On this prism, light is incident at an angle of incidence I and emerges normal from the opposite surface if the refractive of the material of the prism is mu, then the angle of incidence is nearly equal to. So we have to find the I value. This is angle of prism. This is incident ray. After refraction, it will pass like this. After that, it will be emerged perpendicular to the surface. Here R2 going to be 0 because the refracted ray coincides with the normal line. Here I, here R. If we take I1, this will be R1. We know that A is equal to R1 plus R2. A is equal to, where R1 is R1, R2 is 0. So A is equal to R1. Null's law we can apply. Here refractive of medium is mu1, refractive of medium is mu2. Here angle of incidence I1, here angle of refraction is R1. So mu1 sin I1 is equal to here mu2 sin R1. For air, refractive is 1. So mu1 value going to be 1. So mu1 is equal to 1 for air. So 1 into sin I1 is equal to mu2. So mu2 is nothing but refractive of the glass prism. If mu1 is 1, only 1 mu is there. For that, no need to use a subscription, you can take as mu. Then next sin R1. Sin I1, here sin R1. If the angles are very small, we can take only I1 equal to mu R1. I1 is the angle of incidence here. Then mu R1. I1 is equal to mu R1 value is equal to A. I1 is equal to mu A. Question number 123. A 40 microfarad capacitor is connected to a 200 volt 50 Hz AC supply. The RMS value of the current. So we have to find the RMS value of the current. Here given capacitance value C and voltage value and frequency value. We are going to find the IRMS. So IRMS formula is equal to VRMS by XC. Now IRMS is equal to VRMS by XC value is 1 by omega C. That omega C will go to numerator. So IRMS is equal to omega C will go to numerator, then VRMS. Then IRMS is equal to omega formula is 2 pi nu C into VRMS. We know all the values. I is equal to, IRMS is equal to 2 into pi value 3.14 into frequency value nu here 50 Hz. 50 into C value they given in question itself 40 microfarad. So 40 micro means 10 power minus 6 into VRMS. So VRMS is 220 volt, sorry, VRMS is 200 voltage. So if you simplify these things, IRMS is equal to 2.51 ampere. Number 124, dimensions of stress are. So stress formula, we know that stress is equal to force per area. Force for dimension for MLT power minus 2. Then area is L, dimension of L square. Then square L will be cancelled. So L will go to numerator L inverse. Then T power minus 2. This is dimension formula for stress. 125, the Brewster's angle IB for interface should be. So Brewster angle is nothing but at certain angle when the incident ray incident on the refractive medium. In one part of the incident ray is reflected, rest of the part is refracted. So that reflected ray is totally polarized. That angle of incidence is called polarized angle or Brewster angle. So Brewster angle interface IB should be greater than 45 and should be less than 90 degree. This is a direct question. This is the answer. Question number 126. A wire of length L, area of cross section A is hanging from fixed support. The length of the wire changes to L1 when the mass is suspended from its free end. The expression for Young's modulus. Let us consider this is wire of length L, its area of cross section A. Now mass is fixed at the end of the rod, so it is going to be extended. Now length changes into L1. So initial length was L. Now change in length is del L. The del L is L1 minus L. We know that Young's modulus expression Y is equal to stress by strain. So stress is sigma, T you can take as strain. Y is equal to force per area divided by change in dimension by original dimension. Here change in length by original length. Now Y is equal, force formula is mg. According to that given options we are converting that. F is equal to mg. This A will come to denominator, L will go to numerator, del L. Now Y is equal to mgl A. This del L value is L1 minus L. So already we know that del L value is L1 minus L. This is Young's modulus expression. Question number 127. A short electric dipole has a dipole moment of 6 × 10 power minus 9 coulomb meter. You can take as P. The electric potential due to the dipole at a point distance of 0.6 meter. Let us take R from the center of the dipole situated on a line making an angle of 60 degree. This one you can take as theta with the dipole axis. So let us consider this is dipole minus Q plus Q2 equal and opposite charges separated by very small distance. So the line making theta is equal to 60 degree at R is equal to 0.6 meter. At this point we have to find the electric potential V. We are going to find out potential due to the electric dipole P cos theta by 4 pi epsilon naught R square. V is equal P value 16 into 10 power minus 19 into cos 60, theta value is 60, so cos 60 degree. Then this 1 by 4 pi value is 9 into 10 power 9 divided by R. R value is 0.6 whole square. Now V is equal to 16 into 1 by 2. Cos 60 value is 1 by 2 into 9 by 0.6 into 0.6, 0.36. This 10 power minus, actually 16 into 10 power minus 9. So 16 10 power minus 9. This 10 power minus 9 and this 10 power plus 9 going to be cancelled. So for that remaining we wrote steps. So 16 cos 61 by 2, 9, 0.6 whole square is 0.36. Then 8 2s are 16. Then V is equal to, we simply will get V is equal to 200 volt. So at this point the potential is 200 volt. Question number 128. In a guitar, two strings A and B made of same material are slightly out of tune and produce beats of frequency 6 Hz. So beat of frequency 6 Hz means the difference between the strings in frequency is 6 Hz. So modulus of Na minus Nb is 6. When tension B is slightly decreased, so tension B is slightly decreased, the beat frequency increases to 7 Hz. If the frequency of A is 530 Hz, what will be the original frequency of B? So, original frequency of Na is 530 Hz. According to the question is 530 Hz. So, what is the frequency of B? Nb we are going to find out. Now, if you remove the mod, Na minus Nb is equal plus or minus 6. We know that Na value, frequency of string A is 530 Hz. So we want to find out the Nb. So Na, this plus or minus k means minus or plus 6 is equal to Nb. Na value is 530 Hz minus or plus 6 equal to Nb. So there are two values of possibility. If you add together, you will get 536. If you subtract, you will get 524 Hz. In question itself, the given tension in B is slightly decreased. So if the tension is frequency is the square root of the tension. When the tension is decreased, frequency also going to be decreased. So a decreased frequency is 524 Hz. So this is the answer for 128th question. 524 Hz is the original frequency of B. Question number 129. An electron is accelerated from rest through a potential difference of V volt. If the de Broglie wavelength of the electron is 1.227 in 10 power minus 2 nanometer, the potential difference is. So we know that the relation between wavelength and potential difference 12.27 by root V Armstrong. Now we can modify this. We have to find the potential difference V. So root V is equal to 12.27 by lambda. Lambda value is given 1.227. So 1.227 in 10 power minus 2, that nanometer. So nano in the sense 10 power minus 9. Now root V is equal to, if you simplify, we'll get 100. Then V power 1 by 2 is equal to 100. V is equal to, this 1 by 2 goes to that side, 100 square. So V is equal to 100 square 10 power 4. Then V is equal to, we can write V is equal to 10 power 4 volt. Question number 130. The solids which have the negative temperature coefficient of resistance are. So negative temperature coefficient of resistance in the sense when the temperature increases, resistance going to be decreases. If we take insulator at high temperature, it may be possible, but not possible at normal temperature. Insulator and semiconductor. In insulator, not possible, but semiconductor is possible. So that answer semiconductors only is possible. Negative temperature coefficient of resistance. When the temperature increases, resistance decreases only in the semiconductor. But in metals, temperature direct proportion to the resistance. When the temperature increases, resistance also going to be increases. So it is positive temperature coefficient of resistance. So according to this question, option 2 is the right answer. Question number 131. The energy required to break one bond in DNA is 10 power minus 20 joule. This value in electron volt is nearly. This is a conversion. Just you have to convert 1 joule into electron volt. So 1 electron volt value is 1.6 into 10 power minus 19 joule. Now 1 electron volt, this 1.6 in 10 power minus 19 will come to denominator equal to joule. Now this energy we are going to convert into in terms of electron volt. E is equal to 10 power minus 20 joule. That is given energy value in the equation. Now E is equal to 10 power minus 20. This joule value 1 electron volt divided by 1.6 into 10 power minus 19. Now E is equal. If you simplify this, you can cancel. So I'll get 10 power minus 1. So 10 power minus 1 electron volt by 1.6. Now E is equal to, if we simplify this, 0.06 electron volt. This is energy in electron volt. Question number 132. The quantities of heat required to raise the temperature of two solid copper spheres of radii R1 and R2. The relation between these two, the given R1 is equal to 1.5 into R2 through 1 Kelvin are in the ratio. So they are asking the heat ratio Q1, Q2. We know that Q1 is equal to mc del T. For Q1, m1 for first sphere. Next for second sphere, Q2 is equal to m2c del T. We know that density formula rho is equal mass per volume. Then mass is equal to rho density into volume. We can substitute in this equation. Q1 is equal for m1 rho v1 c del T. Then for Q2 rho v2 c del T. Here density is same because the both are solid copper. So both are solid copper. So no, there will not be any changes in the density. Density going to be the same. Now we can divide this equation. Let be equation 1, let be equation 2. So equation 1 by 2 gives Q1 by Q2 is equal to rho V1 C del T divided by rho V2 C del T. This del T C rho going to be cancelled. Now Q1 by Q2 is equal to V1 formula is 4 pi 3 volume of sphere, 4 pi 3 pi r1 cube by 4 pi 3 pi r2 cube. Here 4 pi 3 cancel, pi cancel. So that Q1 by Q2 is equal to R1 cube. So R1 value given in question, R1 is equal to 1.5 R2. So here you can write 1.5 R2, here whole cube is there, divided by R2 cube. R2 cube 1.5 cube R2 cube divided by R2 cube. So this R2 cube going to be cancelled. 1.5 cube is not, we can write as 3 by 2 cube. This 3 by 2 we can write 27 by 8. 3 cube 27, 2 cube 8. This is Q1 by Q2. So the ratio is Q1 is to Q2 is equal to 27 is to 8. This is the answer for 132 question. Question number 133. Which of the following graph represents the variation of resistivity to the temperature for copper? There are 4 graphs given. So first one for semiconductor, second one for copper. So according to that question, second one is the right answer. T did not mention our NCERT book. This is for nichrome. So according to the question, graph plotted resistivity versus temperature for copper, second option is the right one. Question number 134. For transistor action, which of the following statement is correct? First statement, base emitter collector region should have same size. So size is different for base emitter and collector. So this one is wrong option. Both emitter junctions as well as the collector junction forward bias. This one also wrong option because emitter junction is forward bias, collector junction is reversed bias. Then next, the base region must be very thin and lightly doped. This only right option. This is base is very thin and lightly doped. So third one is the right option. So fourth one, base emitter and collector regions should have same size, same doping concentration. This one also wrong one because emitter, base and emitter is heavily doped. B and C, base and emitter collector are lightly doped. So this one also wrong option. So right answer for 134 is option 3. The base region must be very thin and lightly doped. Question number 135. For which one of the following Bohr model is not valid? So Bohr model is valid only for presence of only one electron. If we take singly ionized helium atom or slightly ionized helium atom, one electron will be ionized, so that only one electron is there. So Bohr model is valid. Next, deuteron atom. This is the isotope of hydrogen. So one electron is present. So we can apply the Bohr atom model. Then third one, singly ionized neon atom. So atomic number of or electron number of neon is 10. If singly ionized means there are 9 electrons present in the neon atom. So Bohr model is not valid because here more than 1 electron present in the singly ionized neon atom. So Bohr atom is not valid. According to the question, option 3 is the right answer. Here hydrogen atom, so only 1 electron is there. Bohr atom model is valid. So Bohr atom model is not valid in option 3, that is singly ionized neon atom. Thank you, students.